Hello and welcome to my MS686 final project presentation. Today I'm going to discuss my project and what data it covers and the goals of the project are. So but first I think I need to set the stage by talking a little bit about the data set that I'll be using for my project. So first, let's go over here to Kaggle and look at the data set that I chose. This is a data set for software vulnerabilities where the author of this data set mapped CVEs, that's this column right here, CVE, and you can see there's quite a few unique values, there's 55,000 of them, match them to a CWE. So what is a CVE? A CVE is a cybersecurity vulnerability enumeration. And the purpose of CVEs is for security researchers to contribute vulnerabilities and exploits to a common data set so that other security researchers can talk about the same thing. So in theory, at least the way it was intended to be used was that if a security researcher was researching vulnerabilities for exploitation on a system such as a Linux distribution or some type of application such as like Apache Tomcat, it would, and if they found vulnerabilities or exploits, they could register them and get a number, and that's what this number is right here. For that enumeration. That way, if another security researcher was finding vulnerabilities or exploitable vulnerabilities, they could see if one was already recorded, and that way there would be no duplication. However, it's well known that the CVE vulnerability database the standards are somewhat low, and many cybersecurity researchers, for various reasons, submit these, and sometimes they're talking about the same system, or the data that is provided is very sketchy, meaning that it lacks precision. So it's become, over the years, a wealth of misinformation, and as you can see, from 2013 on, each year the number of vulnerabilities being recorded in this database just keeps climbing. Now, there's a number of speculation as to why there's so many. Obviously, new technology, new updates to systems and new applications that come out every year may have vulnerabilities. This is known, but the essence of the database was to capture true vulnerabilities in systems. However, security tools vendors, most likely, it is just my opinion that they probably contribute to this, and it's been widely, I'm gonna say discredited, but it's widely used, and there's a lot of inconsistencies. So for data scientists, this is a great opportunity to pull this enormous data set and analyze it. There's a lot of data engineering possibilities in here as well to try to find misinformation and correct information. But it's well known in the cybersecurity industry, the problems with the data set. So as you can see, it keeps growing. There's various reasons why, but that's not the scope of this video. But what's interesting about using this data set, if you are a cybersecurity professional, you can use tools like CVE Details. I find this to be one of the best. They've updated their interface recently. But you can search for instance, let's just search for RHEL, so vulnerabilities on the RHEL system, and there we go. And then we can click on here and you can see there's quite a few. They give you a lot of really good data analysis tools just built into this, but we can look at this one right here. So VP9 and libvpx before 1.13.1 mishandles WITs leading to a crash related to encoding. They do give you some scores of how bad it might be or might not be, and they've also began to collect from other data sources. So it's a really good tool if you're a security researcher and you're trying to find bugs in a system. You could go here. This is usually where the low-hanging fruit is to start looking for how, if you're a pen tester, and you're working an engagement on a system. It's very easy to quickly just use the work of others. If it's a Red Hat system I'm looking at, find the version of it. And then if you're targeting maybe a web application, if it's using something like Apache Tomcat or whatever, you could find all the vulnerabilities associated with that patch level and version level and put together a pretty good list of possible exploitation paths. Now, from experience, I will say that 75 to 80% of the leads or recon, as it were, that you're able to find in open source intelligence usually leads to nowhere, but occasionally there are, I would say maybe 20% on a good day, you might find a vulnerability that is real, and you can get some good data on it. But as you can see, the data is pretty limited. A vulnerability was found in this libxpm due to a boundary condition, and then they give you a function call. Of course, you would have to look up libxpm. So if your system doesn't have that library, or this or your application that you're trying to exploit doesn't have this, this CVE goes nowhere. So that's typically how it's used. But with the advances in data analytics tools, it makes it really quick for a cybersecurity researcher to quickly grab some potential opportunities and try and exploit. So this is usually where I go to first to try to find a way into a system. Now, so why are these important? As I said, they give you some indicators of what you might try. If you are targeting Red Hat Enterprise Linux for this version, and maybe it has this library, you could try this, but there's not a lot of data in here. There's no proof of concept, and as you can see, the information varies. So it's widely known that it's a good source, but it does have some limitations. Like here is a good one here, 2023 SQL injection vulnerability in PostgreSQL. So that's pretty good if you're trying to exploit a system that is running a version of Red Hat Enterprise Linux, and you're targeting a PostgreSQL database. Maybe the application is using that. You might try some of these. This one's fairly well documented right here as compared to another one. So that's the CVE database. If we look at the CWEs, now this is a different type of data set, and this is for weaknesses in software and hardware. And these are relatively static. There are quite a few of them. The list gets updated, but it's somewhat static when compared to CVEs because it captures weaknesses in software and hardware. Now, all software and hardware have weakness patterns in them. SQL, if you're using a relational database, it's vulnerable or weak and it's weak against SQL injection. So there's certain methods to use to perform SQL injection. It's just the way it is. If you use that technology, you have those weaknesses. It doesn't mean that you can necessarily exploit the SQL injection. It just means that if the developer didn't practice secure coding practices to guard against that, then you could potentially attack that weakness. All right, so this, just to give you an idea what a CWE looks like. For this one, I'm using, for my example, 352 cross-site request forgery. It gives you some examples of how you might pull off cross-site request forgery, what it is. I will not go into the details of, if you don't know what cross-site request forgery is, you could look that up and learn about it, but that's not the scope of this video. So how do you use these two data sets together? That is what this data scientist or analyst did, was they mapped CWEs to CVEs. This is very, very useful, but it can lead to a lot of misinformation as well. However, when you are trying to find a way to exploit a system, you might use a tool like Fortify. This is a very old tool. It's been around. It's been owned by a number of vendors. I have used the tool for well over a decade now. And what this scanner does is it looks at source code to try to find weakness patterns. Now, Fortify does have hooks into compilers, and it does quite a bit more than just semantic analysis. But for the most part, it's a rules. These types of static application security testing scanners are rules-based and pattern-based. So the power of combining this tool with some data that you can find in some of these databases allows you to quickly put a list together of things you might try. Again, 75 to 80% of it will probably be ineffective because the data set has limited standards enforcement, and so there is just a lot of misinformation in these data sets. But this data set here is an example of a list I might compile if I was trying to exploit a system. However, it would be CVEs filtered to that system, and then my scan results, I would look to see if I had a match, and that's what they're doing here. So this CVE also relates to CWE 252. So as you can see, here is the metadata of what you might try, or the proof of concept. Let's see if I can expand this. So this is an excellent set. You could use this data set today and run a scan on some source code for the target system, and if you found any CWEs, you can then trace them back to the associated CVE. This is a great data set, already created and ready to go. Now, so what if you want to create this data set? How many hours did it take? How long was it to put together? Typically, when I'm performing some type of security research work, I start with the CWE and then I manually build my list. It will be much smaller than this because it's scoped to only the CVEs relevant to the system I'm targeting. But this list here is mapped to all CVEs since 2021. So if you could create a model that could read this text here and see if it was indicative of a type of cyber or a type of common weakness enumeration, you'd be able to quickly build your recon list or potential exploits you might try and work through the list very quickly. This normally takes a good amount of time to put together, but with the tools available to us today, we could apply a little bit of AI and quickly generate these on the fly. And that's what my project is all about.